Hi guys, welcome back to Final Exam Guy, and today we're going to be going through 5 solved problems on the mean value theorem. Before we start, don't forget to subscribe to my channel so to keep updated on the videos I make, and share these videos with your friends so that everyone can learn about the mean value theorem. So, what is the mean value theorem? The mean value theorem says that if f of x is continuous on an interval a, b, and differentiable on open interval a, b, then there must be some number c in the open interval a to b, open interval a to b, that such that if I take this c and plug it into the derivative, I'll get this. Now, this is not easy to explain in this formula, so we'll draw a nice graph and see what that means. Okay, hold on. Alright, if I have interval a to b, and my graph is continuous on a to b, so let's say it looks like this, from a to b. And let's call this point point A, which is just f of a, right? This point is a. This point here, a comma f of a, and this point here is called b. This point is b comma f of b. All right. And if I draw the line connecting these two, and that line is called the secant line. And it has a slope of this right here. This is the slope of the secant line, right? Rise over run. So f of b minus f of a, that's rise over run, b minus a. That slope must equal to the slope of the tangent line at c. So if there's a point c, c comma f of c, there must be some slope, some tangent line here that has the same slope as the secant line. In other words, they're parallel. So basically, let's reread this again. If our function is continuous on an interval a to b and differentiable as well, then there must be some c value in this interval that if I were to take this c, plug it into my derivative of the function, I would get a tangent line having the same slope as the secant line, because this is the tangent line. I guess in other words, to say this tangent line equals secant line, that is their slopes / parallel. Alright, so the problems are going to be like giving you a function and finding if there exists a c in there that does cause the tangent line and secant line to be parallel. So I hope this was clear, and if it's not very clear to you still, just write in the comments and I'll help you out more. So let's go ahead and do some problems now that we've got this out of the way. Alright guys, so the first problem says the f of x is equal to 2x plus 3 on the interval 1 to 4. It's asking us to determine whether the hypothesis of the mean value theorem holds for this function on the interval. So all we have to do is show that this is continuous on the interval and differentiable. If you plug in any value from this interval into there, you get back an answer. So it is continuous at all points in the interval. Obviously, it is differentiable, no problem. So it is the mean value theorem is applicable, and there is some value c in there, such that f prime of c equals f of b minus f of a over b minus a. So there is some value c in there, in that interval, that will give me f of 4 minus f of 1 over 4 minus 1 equals 2. So I can pick any value of c in between 1 and 4, and this will always be true. I'll always get 2 back. They will always be equal, no matter what number I pick in between there. Because look at this. F prime of x, right? The derivative of this is 2. So if I plug c, any value of c between this interval and the 2, we're always stuck with the 2 here, because that happens to be the derivative, so 2 will always equal 2. So the mean value theorem holds. Get it? Alright, so another one. Alright, so all we need to do here, we got a new function here, so we'll take the derivative to start off. Is it continuous for on this interval? Yes, of course. Any value I plug in will give me back something. And is it differentiable? Obviously, yes it is. So 6x minus 5 is our derivative. So the mean value theorem applies here because it's continuous and differentiable. So there must be some value c in the interval 2 to 5 such that f prime of c equals to f of b minus f of a all over b minus a. So f prime of c is basically plugging in c for all x's, and f of b minus f of a, f of 5 minus f of 2 all over 5 minus 2, which is 3. So we get 6c minus 5 is equal to 16. 6c is equal to 21. C is equal to 21 by 6, which is 7 over 2. So that's our value of c for the mean value theorem. Alright guys, number 3, f of x is equal to x to the power of 3/4 on the interval 0 to 16. Is it differentiable? Yes, it is for all x greater than 0. And is it continuous? Yes, any value you plug in this interval into that function, you'll get back something nice. So what we would do here is we would take the derivative, f prime of x, and that's going to be 3 over 4 times the 4th root of x. So now that we know that there exists some c such that f prime of c is equal to f of b minus f of a over b minus a. So if I plug f prime of c is equal to 3 over 4 times 4th root of x, c, this must equal to f of b minus f of a. So f of 16 minus f of 0 all over 16 minus 0 is 16. So that in this case, it's 8 minus 0 over 16 is equal to 1/2. So if you set these two equal to each other, 3 over 4 c, 4 is equal to 1/2. With a little fancy algebra, you'll see that c is equal to 81 over 16. And this c here does lie in this interval. So obviously the mean value theorem works out nicely in this problem. Let's move on to number 4. Alright guys, this function here is x plus 3 over x minus 4 from the interval 1 to 3. If we plug in any of these values from 1 to 3 here into this function, we'll get back something nice. If this was a 1, for example, and I plug in 1, then we would have something over 0, which is the mean value theorem would fail. So there must exist some c in there, such that f prime of c is equal to f b minus f a over b minus a. So f prime of x, in this case, we get, using a quick quotient rule, so low times the derivative of the top is just 1, plus high and the derivative of the bottom is just 1 all over the bottom squared. So f of c is equal to c minus 4 plus c plus 3 all over c minus 4 squared, and that must equal f of 3 minus f of 1 all over 3 minus 1 is just 2. Alright, so this first term here just reduces to 7 over x minus 4, c minus 4 squared, and then that must equal to negative 7 by 3. So solving here, we get c minus 4 squared is equal to 3. C minus 4 is equal to plus or minus root 3. So c is equal to 4 plus or minus root 3. So only the good c you would take is 4 minus root 3, because that's the only one that lies into the interval 1, 3. The other one does not. So the mean value theorem works for the c over here. Alright guys, so the last problem is f of x is equal to square root of 25 minus x squared on the interval negative 3 to 4. Is it continuous? Yes, if we plug in all values, we don't get nothing strange. It is differentiable since 25 minus x squared is greater than 0, no matter which value you put in here, so it's differentiable. So let's find f prime of x, and this is going to be a chain rule. So if we make this, you can also say that this is 25 minus x squared to the half. So if we apply the chain rule, we get 1/2 25 minus x squared to the negative half, multiplied with the derivative of the inside, negative 2x. And this change just simplifies to 1/2 times negative 2x all over root 25 minus x squared, which is equal to negative x over root 25 minus x squared. This is a multiplication, just by the way. Okay. Alright, so f prime of c equals negative c over root 25 minus c squared, and this must equal to f of b minus a, so f of 4 minus f of negative 3 all over 4 minus negative 3 is 4 plus 3. And so from this we get negative c over root 25 minus c squared is equal to negative 1 by 7. And then we can get 7c is equal to root 25 minus c squared. So 49c squared is equal to 25 minus c squared. C squared is equal to 1/2. C is equal to plus or minus 1/2 rooted. Alright, so that means that from the interval, let me just go over one to a little bit to the side for you guys, or under. This just means the interval we have is 3 to 4, negative 3 to 4, and both of these, whether it's 1/2 root is positive or negative, they both fit in the interval, so we've applied the mean value theorem, everything works out fine. Alright guys, so that's the end of my mean value theorem video. I really hope you learned something here today. If you did, please support me by subscribing. Come on, it's the least you could do. And share this video with your friends and smash that like button. So I'll see you guys in the next solved problems video. Take care.